The current study sought to determine if French newborns, when secured on a mini skateboard known as the crawly skate, would modify their quadrupedal locomotion and their head orientation in response to encouragements to move offered in their native language compared to a rhythmically different unfamiliar language. Given prior evidence of rhythm-based language discrimination, we predicted that newborns would show different crawling and head orientation behaviour in response to their native compared to the non-native language. 23 French newborns were randomly assigned to two randomly ordered 2-minute trials consisting of sentences repeated in French or sentences repeated in English. The sentences were matched on content, words, syllables, and were broadcast by a speaker on the left or right of the newborn. The newborns were tested on the crawly skate, which is pictured on the right and was designed to facilitate crawling. We measured crawling distance, the number of leg and arm steps, and head orientation using 3D motion capture and 2D video. As depicted in the graph on the right, when hearing French, their native language, compared to English, the newborn's crawling was enhanced. They took significantly more leg and arm steps. They're not depicted here. When hearing French, newborns also made significantly more and larger trunk rotations in the cephalocaudal axis. As depicted in the graph on the right, newborns oriented their head toward the appropriate loudspeaker when hearing French. In other words, they turned their head toward the left when the voice came from the left, and to the right when the voice came from the right. This was not the case when hearing English. Though not depicted here, newborns oriented their trunk toward the appropriate loudspeaker when hearing French, but not English. In conclusion, newborn crawling is enhanced when they hear their native language, consistent with crawling enhancements seen when newborns are exposed to optic flows and the maternal breast odour. These findings provide additional evidence that newborn crawling can be modulated by information that is processed supraspinally.